Does it make sense, Sakina? Or second part is still not clear? So what we did is t prime, we put t prime is equal to 0 because this is the way we get the minimum or maximum value. And we got v is equal to 10. For that, when v is 10, then you get t prime as 0. Then we also check t double prime. And t double prime at t 10 was positive. So that means t prime is 0, means it is either minima or maxima, and t double prime is positive, means it is a minima. Sakina, does it make sense or not?
Yes, it makes sense also.
Okay, so this is the way we did. What else you want to ask before we get into the 24 also is a problem or clear? Same thing. Optimization problem is the same. First, you need to find the function in one variable, and then you need to optimize that function to see when you can get maximum or minimum value in the given range of variable. Okay, there any question? Okay, so let's go to the did you guys do that assignment, partner?
So I have like maybe a few pages left, but I've done most of it.
Most of it. Any challenge or any question you want to discuss?
No, not so far, so.
All good? Okay, that's good. Um, we did HSC question. So let's do this one. Exponential. So what we also did, Sakina, in the last class. You have gone through the video, right? Sakina? Okay. So we also did the tangent of the equation, differentiation of the exponential function. We did application of the exponential function. This is what we were going to do. So sketch the graph y is equal to x e to the power minus x after carrying out these steps. Write down the domain. What is the domain, Sakina, for this one? What x value can be? Sakina, any challenge in this domain? Finding the domain means what x value it is possible.
Is it all real X values?
Sorry?
Is it all real X values?
All realized because x is not having any constraint and e to the power minus x is also not having any constraint, whether it can be domain with the everything. So we will get all domain. That's okay. Now, next one. Test whether function is even or odd. Pratna, can you check? Both of you can check whether function is even or odd, which we did before. What did you get, Pratna? Even or odd? Or neither?
Just 1 second, sir.
Sakina, what did you get?
I got neither, sir.
Neither. Sakina, did you get or not?
Yeah, I got neither.
Neither, right? Because we'll start with f of minus x and we'll say neither. And did you know how to find out, Sakina and Pratna? Okay. Find any zeros of the function, examine its sign. So then you need to do f prime x or y prime is equal to 0. There is no discontinuity because it is on minus infinity to infinity. So you will not get zeros or critical points from that one. So f prime x, if you put that f prime x is equal to 0, what is f prime x? X e to the power minus x. So y prime is ddx of product rule you need to put, which is first you differentiate plus e to the power minus x. So basically 1 minus x e to the power minus x. Is it? What do you get? This is what you get. Hmm?
Yes, sir.
Okay. So when you put this is equal to 0, you put y prime is equal to 0, you get x is equal to 1. Only 1 0 because this will never be 0. E to the power minus x graph is like this. E to the power plus x graph is like this. So you will never get this thing. Examine the function's behavior D part when x tending to infinity. So when x tending to infinity, e to the power minus x is tending to 0, isn't it? When x tending to plus infinity. And x will tend to infinity. The multiplication, you don't know whether it will tend to infinity or 0. Clear? So we have a doubt whether y will tend to infinity or 0. Any idea, Shakina? Because when x tending to plus infinity, x is very large. This is tending to almost 0, and this is tending to infinity. Because x is infinity, so x is tending to very large number, but e to the power minus x is a very small number. So what we don't know is whether product of these two will move to large number. Who is going faster? Any idea, Sakina? Pratna?
Does y approach 0 as x approaches to infinity?
I don't know. So that's what I'm asking. What is the reasoning to say that infinity or 0? What will be the reasoning for that? So let's look at some concept which may not be good for Australia, but it might help you. So what happens is I can write y is equal to x divided by e to the power x, right? This is a function. And when x tending to 0, when x tending to 0, or sorry, infinity will start with infinity, plus infinity, let's say. That is infinity by infinity, this form. So y has infinity by infinity form. So we don't know the same thing what you have here. Same thing I have written in a different way. So this form or 0 by 0 form, if you put that value of infinity or 0, 0 by 0 form, infinity by infinity form, if you get in a function, you cannot say until you get to the next level whether it is tending to real infinity or 0, whatever. Clear, Sakina? Does it make sense? So now, what is the idea? Idea is if y is, I'm telling you a method which is not taught in Australia, but it is quite useful. What do you do if you have y is equal to u over v? You differentiate u separately and v separately. So look at the u prime by s by v prime. So in this case, what will happen? If you differentiate x, you get 1. If you differentiate e to the power x, you get e to the power x. Isn't it? New y. Let's say call it y1. Clear? Now look at this y1 where it is tending. So when x tending to infinity, this is 1, right? But this is tending to infinity. So 1 by infinity means 0. Clear? This is called, if you want to search on internet, this is called L hospital rule. L hospital rule is what? If you are getting this form, either 0 by 0 or infinity by infinity form, when you are trying to get the limit of any function, if you find any of these two form, and then and you are not sure how that is going to work, then you use this rule where you differentiate numerator separately, denominator separately, and look the limit of that new function. Clear, Sakina, Pratna? And it is only valid when you get this form, when you are not able to decide by putting this form. So now what will happen? It is tending to 0. I have seen from L hospital rule, right? Clear? And the reasoning in Australia, the reasoning is this function goes to infinity faster. This goes to infinity slower because it's a linear function, right? So this will dominate e to the power x. So 1 upon infinity is 0, which you got here anyway, the same thing. But which function or which part is going faster to infinity is a thing. Clear, Sakina? Clear, Pratna? Let's look at x tending to minus infinity. So e to the power x tending to 0 and x is tending to minus infinity. So minus infinity divided by 0 is actually minus infinity, isn't it? Because 1 by 0 will anyway increase the infinity value. Clear? So when x tending to minus infinity, what is happening to the graph? Y is also tending to minus infinity. Clear? Pratna? So we got x tending to minus infinity. They are given actually. You may assume that x tending to infinity. They have sent you assume I have told you the L hospital rule. Let's do one practice for L hospital rule again. Find any stationary point or examining their nature. Let me give you another question. Same way you can do, let's say I am asking you another example for L hospital, and we'll keep this L hospital rule in a different color. Let me put this way. So if you have another rule called find y is equal to limit x tending to 0 sine x divided by x. So if you look at x tending to 0, when x is 0, sine x will be 0 and 0 x is also 0. Isn't it? Both are 0 by 0 form. You cannot find out like this what is the value if this whole function is tending to when x is tending to 0. So I will say that this is same as saying limit x tending to 0, differentiate sine x prime and x prime. What will be that limit? This is same as limit x tending sine x is cos x and x prime is 1, right? So when you say that now limit x tending to 0, cos 0 is 1, right? So this will tend to 1, which you would have never thought that this value will tend to 1. So sine x divided by x when x tending to 0 is actually 1. Here, both of you? Here? So this is the way it works, the L-hospital rule. Okay. But here in Australia, you might need to do the, you can find out that in, and then you can say e to the power x is tending faster, or e to the power x is going slower to infinity, and then you can write down that. So x plus infinity minus infinity is done. Let's look at the another part. Find any stationary zero of the function we already got. Find any stationary point and examine their nature. So we already got a stationary point x is equal to 1. Now find their nature. Can you find out their nature? This point was x is equal to 1. If you put x is equal to 1, you get 1 by e, right? So e part, stationary point is 1 comma 1 by e, right? That is the point where you have f prime or y prime is 0. Now this point is minima, maxima, concave up, concave down. You need to find out. You can use a table also if you want. So it is near 0, so 1, 0 maybe, and 2. This is x, this is y prime. 0 at 1, at x is equal to 0. What is the f prime is 1 minus, so that is positive, right? And 2 is negative. So definitely it is a maxima. Or you can say f double prime if you want to find out. What is f double prime or y double prime value?
It's negative e to the power of negative x. And then in brackets 2 minus x.
We can write x minus 2 directly taking this. So it is e to the power negative x into x minus 2, what we are saying, right?
Yep.
Y double prime at x is equal to 1, which is our point for stationary. If you look at it, is a negative number, which is around minus e to the power minus 1, which is minus 1 by e, which is a negative number, right? So f double prime x is negative means it is a maximum concave down. So either you check by this or you check by this. Both should give the same answer. Any question, Sakina? Does it make sense?
Just one question in the stationary point one. How did you get 1/e?
I did not able to hear you, Sakina. Can you speak a bit louder?
Sorry. For the stationary point, the how did you get 1/e as the y value?
Oh, so x is equal to 1 you got in part B, right? C.
Yeah.
So, or maybe you can do f prime x is equal to 0. And if you put x is equal to 1 in y, you get y is equal to 1 times e to the power minus 1, which is 1 by e. So basically that is a coordinate of the point where you got f prime x 0.
Okay. Yeah, that makes sense.
Clear, Radha? Done? Any question?
No, sir.
F part. We need to see the concavity. So let's see where is y double prime 0. Because y double prime is equal to 0 if you see is at x is equal to 2. But we need to see whether x is equal to 2, the sign is changing of y double prime or not. Right? That's what the condition is. So first thing, you got point of inflection if y double prime x is 0 and it is changing the value at 2. So I'll look at 2, 1 and 3. So let's say y double prime and then this is x. So y double prime value is x minus 2. So at this one, at 1 it will be minus e to the power 1 by e. At 2 definitely it is 0. At 3 it is plus 1 by e cube actually. Right, which is positive. So negative, 0, positive. So it is changing the concavity, right? Earlier it was concave, up, up or down, Pratna? If y double prime is negative, then it is
Concave down.
minimum. Clear? So it is changing a concavity. Shakina? So it is a point of inflection. So it will be something like this. First negative. So it will be, graph will be like at x is equal to 2, graph will be like this. First it will be concave down, then it will be concave up. Let's look at the graph. You don't need to draw that graph, but let's see if I can bring that graph. That graph is too steep, maybe. Not able to see properly how that graph looks like. But very lengthy, leave it. So that x is equal to graph will be something like that. Or maybe they have given the graph something like this. It will be. If it is increasing, this will be like this. This is for increasing part. And if it is decreasing, then it will be like this in this scenario. Concave down and concave up. I think this is the case of where you have this decreasing part. Clear? Sakina? Pratna? Any question? Let's look at, maybe you do that. Now what they have done is they have created a function, enrichment question, that you do as a homework. Here they have put the absolute value of x. So this is something you do as a homework and see if you can do that. Now let's do the differentiation of the log. So same differentiation of the log function. If you say ddx of ln x, again, this and this should be the same. Then you get 1 by x. Assuming that 1x is positive here. Clear? So this is a log differentiation. So if you have log x square plus 1 ddx, so first you'll use the chain rule. First you do the 1 by 1 plus x square, which is a log complete thing, and then ddx of 1 plus x square, which is 2x. The answer will be 2x divided by 1 plus x square. Here, Sakina, Pratna, let's do this one, this question. Find the gradient of the tangent y is equal to, and this is a ln x, right? So if you have been given log, you know, log is base 10. But this is ln, where ln is log x base e. Right? So always differentiation is defined for this one, not for log x. If you have been given log x, what you need to do is you need to convert that into a ln x. So log x base 10 is same as log x base e divided by log 10 base e. Right? You can write that. Do you remember this log thing, Sakina? Do you remember?
Little bits of it.
Sorry?
I remember little bits of it. I remember the differentiation though.
Sakina, I did not able to hear you properly. What did you say?
I said I remember the differentiation part.
Okay. But what I am trying to tell you here, other than differentiation, you need to also understand it is a log base ex, which is 1 by x. If it is not base e, it is base 10, then you need to use this conversion to do the formula. Okay. So if you have log x base a differentiation, first, because this is a constant value, first you need to understand, you need to have 1 by log a base e into 1 by x. That's what I'm trying to say. So this you need to convert into this, and this is a constant value. So it will be out, and then differentiation of this one will be 1 by x. Does it make sense, Sakina? Pratna?
So I have a question.
Yeah.
For part A, it says at its x-intercept. What does that mean? Like, what is its x-intercept?
Okay, so when you draw this graph, y is equal to ln x, all the log x graph is like this. Whatever base it is, right? This is like this. So it will always be 1, 0. For any log function, x-intercept is always 1, 0, because when you put y is equal to 0, log x is equal to 0, then it has to be at 1. But when you change the base, only thing which changes is, so let's look at the little bit about the graph of log x. So whether it is a ln x, or let me bring that here from the so I can explain better. Give me a second. Let me bring that graph. And that will clarify some of your doubt. So before even we do this question, let's look at the graph. So let's look at. So log, this is a base 10, right? Your red one, oh, you can't see which one is red one. Let me bring better. See. So red one is log x base 10. This is base 10, right? This is base e. Clear? Shakina? So you can see both are passing through point 1 comma 0. So 1 comma 0 will be a common point for any ln graph or log graph. Depending upon the base, e value is approximately 2.3, right? So you can see the moment your base is increases, graph goes down. So in this one, if I add one more graph, let's say y is equal to log base 4, let's say log x. I don't know whether I can do log x base 4 or not. Let me see if I can do. Function. Yes, I can do. That is a good example. Now you will understand better. Let's look at this graph. So the blue one is base E. Red one is base 10. Blue one is base E. And green one is base 4. So as you increase the base, graph is going towards the x-axis, isn't it? Because this was base which is around 2, then 4, then 10. But all will pass through the point 1 comma 0. Pragna, does it make sense? That was your question. So 1 comma 0 is a common point. Where the difference comes, let's look at in this graph. Let me see if I can bring that also. So at x is equal to 1, it is 0. Let's see x is equal to 2 values. So if you see x is equal to 2 value here for all the graphs. So one thing is here it is going x is equal to 2. This has some value. This has different value. This has different value. And you see that value will increase as the base goes down for any value after 1. Clear? So log x, ln x will have the highest value at x is equal to 2. When you go after here, your ln x or lower base will dominate in the value, and higher base will be having less value. Clear, Pratna? Sakina, can you see that? Okay, so now let's go to the question. So find the gradient of the tangent y's. Any log x graph, x-intercept is always 1, comma 0. But what they want is they want you to find by putting, you will say that, okay, x-intercept where y is 0 means ln x is equal to 0 means x is equal to 1. Right? So 1, comma 0 is x-intercept. Clear, Pradhan? And then prove that always increasing. You can find y prime. First of all, the domain is x positive. You cannot have x negative or x zero even for log. Domain also I'll write. Domain y is equal to log x. Any base, positive, it will be always positive, but any base, x is only greater than 0. Yes, we cannot have a, you can see the graph here, it will never touch the y-axis is a vertical asymptotes for this one. You'll never reach x tending to 0. Clear? Question, so y prime if you see is 1 by x. And since domain x is positive only, y by y prime is always positive. Clear? It can be negative if x is negative, but domain itself is x positive. So y prime is always positive, means it is always increasing function. Shakina, clear? Question? Okay. Now, yeah. Let's do this one. Differentiate each function. Can you tell me, Shakina, for a part, what will be the, if I do that differentiation ddx of ln 3x plus 4, what will be the differentiation using chain rule? Shakina?
Is it just 1 over 3x plus 4?
So it will be 1 over 3x plus 4, but we can also differentiate 3x plus 4, right? Because we only know about x, so that will give you 3. 3x plus 4. Clear? And this is the formula, but I want you to remember the chain rule. This is a chain rule. Standard method is, I'll explain also the standard method here. Generally, when you only know ddx of ln x, and that you call it x, 1 by x. So what you need to do, you need to assume that 3x plus 4, this is a standard method up to extension 2 for integration and differentiation. So what will happen in this case, if you assume that, then du by dx is 3. Clear? Second step, ddx of ln 3x plus 4, I can write as ddx of u, because that is my u, but I can't differentiate u with respect to x. So what I'll do, I'll ln u. I only know differentiation of ln of something with respect to that something. So I will convert that into a ddu of ln u and then du by dx, because that du will cancel. And this is actually a chain rule. And then this is I can write 1 by u, and du by dx we already found is 3. So answer is 3 by u, and u we have introduced in this, so we need to replace by x. So this is a standard method which is applicable everywhere. Integration differentiation called substitution method. But you can also remember this formula. Does it make sense, Ratna? Shakina, does it make sense? So if you forget anything, or if you're not sure whether chain rule, product rule, use this substitution method. That is kind of, what do you call it? Maybe Brahmastra, maybe in that will apply everywhere. Okay. Now, so this is what we have. Do that one. These questions, few questions, you will be okay. What I am interested in the application of that. Let's do this part. So now what they're saying is show the tangent of y is equal to ln x at t has equation this one. The steps are still the same for finding the gradient of the tangent, and then at that point what is the gradient of the normal and tangent. That's it. Can we get this one? I'll get a water. You guys do this one. And same gradient of the tangent, find out by differentiating, then find out from gradient of tangent, gradient of normal, and then find a line, straight line equation passing through a point where you know the gradient. Okay, do this one. Done? Ratna, did you able to do?
Yes, sir, I've done it.
Okay, let's do it. Sakina, where are you? Able to do it or not?
Sorry?
Did you able to do this one or not?
No, I kind of got stuck.
Okay, did you get the, okay, so gradient, let's talk about tangent first. Gradient of tangent is equal to TDX of ln x, right? Which is 1 by x, isn't it? And I'm calling it gradient of m of a tangent. So gradient of a tangent for curve ln x, that is a gradient. Now gradient at e comma 1, isn't it? That will be 1 by e. Clear? So at the point t, the gradient of the tangent is 1 by e. Now equation of tangent then, because tangent is passing through point 1 comma e comma 1 and has a gradient 1 by e, right? This is the point. So you have y minus y1 is equal to x minus x1. And when you solve this one, you get y minus 1 is equal to x by e minus 1. Minus 1 cancel. You get y is equal to x over e. So, or x is equal to ey. That is the equation of the tangent. Clear, Sakina? What was the challenge?
I didn't do the y minus 1 and the x minus e.
Okay, because that point is a very important point. It is on the tangent, it is on the curve. So it has two properties. This T point is on tangent, actually three properties. On normal. In these kind of question, this point is quite important on the curve. So it will follow all this relationship. Clear? Now for normal, only thing which will change is exactly same. The only thing will change is the gradient, which will become minus e, right? So y minus 1 is minus ex plus e square, or y plus ex is equal to 1 plus e square. Did you get Pratna? Same thing?
Yes,
Pratna?
I got the same thing.
Okay. So I think we will finish it here because we did that part.
So I have a question.
Yes.
For this one, do you have to put ex, the plus ex to the other side, or do you just leave it as y plus
Ah,
e?
doesn't matter.
Okay.
But generally, you have been taught as y is equal to mx plus b form. So that is also okay. Okay.
Okay.
Like in this case, they have asked x is equal to not y is equal to mx form. They ask for x is equal to ey to prove, right? There is no standard. But as far as you are, just to make sure that you meet the ego of each teacher, better you put it mx plus b form.
Okay.
Because you never know what ego that teacher who is checking your notebook is keeping, right?
Yeah.
But there is nothing wrong if you put y is equal to ex, because ax plus bx is equal to c is also equation of the straight line. Okay, all good. This is what I wanted to do. This second question is your homework, and do these exercises. So next class, we will try to finish 7ABC also, but you need to finish 6G. What I am interested is 6C and 6H. You finish all the questions from Cambridge. Okay, clear? I have another class, so maybe you guys will discuss and finish this chapter by Tuesday. Take care. Bye.
Thank you, sir.